up where we left off yesterday in 12.2. We are continuing talking about conditional probability. This back page is applying conditional probability formula, which if you go back to the beginning of the conditional probability formula, that very first one we gave, which was the probability of B given A, probability of A and B on top, divided by the probability of A on bottom. Okay? First example. A band's marketing agent conducted a survey to determine how many high school fans the band has. What is the probability that a surveyed student plans to attend the band's concert and is a fan of the group? Okay? So we're asking a little bit different question here, which means we're going to have to work with our formula a little bit, because it's asking probability a surveyed student plans to attend the band's concert and is a fan of the group. Now, I think the easiest thing for me to do is let's set up our conditional probability, and then I'll show you how we can use our formula, okay? And some of this also depends on, we have this limited information, okay? It's not like we have the data where we can come up with various probabilities. We have this limited information here that we're going to use. So it talks in there about probably a surveyed student plans to attend the band's concert. So at that point, we're talking about them being a fan, right? So we're going to look at, where was it? So probability that the student is a fan, given they also plan to attend the concert. Okay, that's the formula I want to set up here. So probability that the student is a fan, given they want to attend the concert. Okay, and of course, I'm going to continue using just basic shortcuts here. Now, based on our formula from yesterday, what do we set up? On top, it's going to be the probability of what? Okay, probability they are a fan and attend. On bottom, probability that they attend. So probability of the condition. Now, before I fill in numbers, and we could do this either way. We can fill in numbers and then move things around. I'm going to go ahead and move things around. And it's based, you'll see it's based on what we know here. We're going to end up searching or finding what they're asking right here. Probably the student plans to attend and is a fan. Okay, so if I'm trying to solve and find this top piece here, how do I get rid of the denominator? In other words, I'm trying to move this formula around. How do I get rid of this denominator and put it on the other side? Multiply, right? If we're dividing by the probability of attending, then we're going to multiply it to the other side. Does that make sense what I'm saying there? I could even write in a little bit of a work here. But if I multiply it by this side, and we multiply it by this side. Okay? The idea is that the probability to attend cancels out here. Okay? Just basic math. I'm going to flip my sides. So we're looking at the probability of being a fan and attending. And that's going to be equal to these two pieces from the left. The probability of being a fan, given they attended, and then times the probability that they attended. Okay. Now, we have to pick out what information we need here. probability that they are a fan given they attended the concert. Okay, where's the number we're grabbing for that one? Okay, we have to look here, students who plan to attend, right? And then 80% of students who plan to attend are fans. So right there, we're going to use 80%. Now, we're working with probability. What do you usually turn that into? A decimal. So I'm going to call that 0.8. It's 0.80, but I'm going to use 0.8. Okay? Times. Probability. Someone plans to attend. Okay. Probability that they plan to attend. In other words, not in relation to fan or not, just 70% of the students plan to attend. What is that as a decimal? 0.70 or 0.7. Okay. Do the math. I didn't think to tell you to grab calculators, but hopefully you thought about it. 8/10 times 7/10 is 56/100, which, based on the fact that this chart was given in percents, what could we say here? 56%. Okay, so a way to use our conditional probability formula, okay, is to be able to move things around. And again, we also have to look, it's based on the fact of the limited information that we are given here. Okay. This other question that goes along with it, what's the probability that a surveyed student plans to attend but is not a fan of the group? Okay, so we're asking probability that a surveyed student plans to attend and is not a fan of the group. Okay, again, it's looking for that top piece here, except it's going to be not a fan and plans to attend. So I'm going to do the similar type thing that we just did on the other one, in that I'm going to set up our conditional probability. This time, though, instead of saying a fan, given they attended, we're going to say not a fan. So probability of not being a fan given they attended a concert. Okay, formula. What is my formula there? On top, you put what? Put both. Probability that they are not a fan and attended, divided by probability of the condition, so probability they attended. Now, do you see how we can manipulate that around again? Okay, it's the same thing of what we just did. We're being asked to find probability they are not a fan and attended. Okay, that's the piece we're being asked to find right there. So if it's dividing by the probability of attended, what do you do to get the probability of attending to the other side? You multiply it over. So now I'm going to have the probability that we're not a fan and attended, and that's going to be equal to the conditional probability from the left, probability of not a fan given they attended, times my denominator, probability of attending. Okay. I'm going to keep going over here where I have a little bit of other room. Probability that they are not a fan given they attended the concert. What'd you say?
20%.
And why?
Because you have 80% who are attending and are fans, so you 80% minus 100%, give you 20%. So it'd be 0.2.
Are you guys with them there? Okay. If probably they're not a fan but attended, we have to look at those who attended, right? And right there, 80% are fans, so that does leave the other 20% that are not fans. So that is the 0.2 times. I just read the wrong thing, didn't I? No, I did. Okay, we're good. Probability they attended. 70%. Okay, because it's still 70% of students plan to attend. Okay. 2/10 times 7/10. 1400ths, which is 14%.
The setup's harder than that.
It is.
Yeah.
This particular problem is it's the tricky setup. Okay. I hope yesterday should have definitely seemed easier than this.
Yeah.
Okay. It's the manipulating around that it gets difficult. I get it. And I personally, when they give us a chart of information in this type setup, I find it hard to follow. I'm not gonna lie. I think this is a tricky problem. So.
It's like they've already done the work for us. You know?
Yeah. But it's hard then because you have to decipher which number do I need. They did the work, but which number are they wanting me to use here? So, yeah, I'm not gonna. It's a tricky one. I agree. Okay. Okay. Got what we need here? Okay. These last two are using conditional probability to make a decision. So, a marketer is looking at mobile phone statistics to help plan an online advertising campaign. She wants to find out which of her company's products is most likely to be purchased after a search for that product on a mobile phone. Okay? Now, if you look here, so we're looking at mobile phone searching and buying behavior. So kind of the connection between you search for something and do you or don't you buy it. She's got 4 products here, W, X, Y, and Z, because of course, what else will we have them, right? And then we have some information. We have information about searching, okay, how often these were searched, and then search and buy, okay? So the idea of how often they were searched and then bought. Now, with that in mind, we want to know which one is most likely to be purchased after this related search, after the initial search. What's my setup? What's our formula here?
Would it be P of the P of the given product, W, X, Y, and Z, and it'd be 46, and then the next number.
Okay, so now, so let's talk general formula, because here's the deal. We have 4 different products happening here, yes? We're going to have to do this formula 4 different times, okay? Because the idea is then going to be using the formula to decide which one is the better, or I started to say better deal, but most likely to be purchased based on the searching, okay? So our conditional probability here, probability that you bought the phone given you what? You searched it, okay? And I'm going to they use B and S here, yes? They use search, or S for search, and they use B for buy, okay? So up there that says purchase, so probability that you bought it given you searched it. Okay, set up our basic formula. We'll plug numbers in here in a little bit. What goes on top? Okay, this is bought and searched, right? So probability of B and S. What goes in the denominator? Probability of searched, yes? Do we have this information in our chart? Probability of searched is the first column. Probability of bought and searched is the second column. Now, what are we doing this for? W, X, Y, Z. Okay? So, let's look at W. I'm not going to rewrite this formula out every time, folks. This is our guideline, right? Let's fill it in. Are we good with that? So for product W, probability of bought and searched. What is that?
16.
That is 16%. Of course, I'm going to use 0.16 times, or not times, goodness gracious. Not times, but it's going to be divided by probability of search. What's the probability that product W was searched? 0.46. You got calculators, right? Plug it in. Okay. I wrote down 0.3478. When I change them to a percent, I have them percents to one decimal place. So this would go to 34.8%. Okay. Hold that information, yes? That is the probability that product W was bought after being searched. Now, what do I need to do? Okay. XYZ, here we go. Okay, product X. Probability of bought and searched on top, which is 14% or 0.14 divided by what? 0.32. Calculator says 0.4375, which is what is a percent? 43.8%. Okay, X is better than W. That's what I know so far. Continue. What about Y? Probability it was bought and searched? No, not on top. 12%, so 0.12. Divided by probability it was searched. There's the 0.35. 0.12 divided by 0.35. That's probably a rounded thing, isn't it? Okay. And I wrote on my paper 0.342829, whatever. What does this become to one decimal place? 34.3. Okay. And product Z. Probability it was bought and searched? 15% divided by probability it was searched. 40%. What do we get here? 0.375, which becomes 37.5%. The question was, which of our company's products is most likely to be purchased after a related search, after a search for that product? And that is what? Yeah, product X. Product X has the highest probability. Okay. And there's our work to support it, right? Okay. One last one. The marketer also has data from desktop computers. Which product is most likely to be purchased after a related search?
Same.
It is. Okay. Again, you're given information about searched versus searched and bought then. Okay. So, similar setup here. Probability of bought, given it was searched, is probability of bought and searched divided by probability of searched. And we have 4 products to do this for. Okay. Now, for J, what are we putting? 10% over 35%. Technically, I don't know if you guys want to or not. You could technically change this, take the decimals out and just make it 10 over 35. You could do that. You wouldn't have to type the decimals then. Okay, what do we have? 0.2857, which becomes 28.6%. Product K. (9% divided by 28%), which is 0.3214 or 32.1%. Product L. (8% divided by 26%). Remember, 8% is a decimal, is 0.08. And we have 0.3077, or in other words, 30.8%. But we have M. And what about M? Okay, 0.05 divided by 0.24 divides to be 0. I'm going to go 2083, good enough for me, which becomes 20.8%. Who has the highest conditional probability? Okay, so this one, product K, has highest conditional probability. Okay, guys, that's what you are looking for. Okay, so conditional probability, read carefully. You have to watch the setup, right? There's probably going to be a few confusing ones. It wouldn't surprise me. Work at it, though. Lesson 12.2 is due tomorrow.